Okay, students, so today we are about to discuss the revision exercise 1 of grade 7. Okay, for the first term. In your textbook, students, it's in the page 108 so that you can refer the questions in that book. Okay, so let's start from the first question. Revision exercise 1. The first question is, the first question is 15 plus 13 plus 12. So what we are supposed to do here is you need to add. So it's a simple question. So let's add 15, 13, 12. If they have given in this way, you write it in the way that you know. Okay. So 5 plus 3 it's 8, 8 plus 2 10, 1 plus 1 2, 2 plus 1 3, 3 plus 1 4. So the final answer is 40. Second question, the Roman number 2, Roman number 2, 18 minus 12 plus 18 minus 12 plus 6. So here first you have to subtract from 18. If you subtract 12, it's 6. 6 plus 6, the answer is 12. So the third question, 9 plus 6 minus 8. 9 plus 6 minus 8. Now see 9 plus 6, if you add these two Buddha, you get 15. 15 minus 8. If you subtract 15 minus 8, the answer is 7. 7. Next one, question number 4. 8 times 7 minus 12. So 8 times 7, we already know. 8 times 7, the answer is 7 times 7 is 49 and 7 times 8 is 56. 56 you subtract 12. So see 6 minus 2 it's 4. 5 minus 1 it's 4. So it's you can subtract like this. 6 minus 2, ones place subtracted by the ones place, the tens place subtracted by the tens place. Okay. Next, the fifth one. 7 times 3, 7 times 3 plus 7 times 3 plus 5. So 7 times 3, you know it's 21 plus 5. The answer is 26. Question number 6. Question number 6. 24 minus 18 divide by 3. So in the theory class, students, I have discussed about a method. We give priority for the BODMAS method. Now in grade 7, you don't need to study about the O part, but you have to learn about the brackets, division, multiplication, addition and subtraction. This was discussed in the theory class and this is the priority order. If you see division and multiplication, give priority to division. If you see addition and division, give priority to division, like that. So in this case, you should give priority to division. 18 if you divide by 3, the answer is 6. 24 minus 6, the answer is 18. Let's go to the fifth one. This is sixth. Let's go for the seventh one. 15 plus 18. 15 plus 18 divided by 3. 18 you divide by 3, the answer you get is 6. 15 plus 6, you'll get the answer 21. Question number 8. 16 plus 5 multiplied by 3. 5 times 3 is 15. 15 plus 16, if you add, you'll get 31 as the answer. Question number 9. Question number 9. 15 minus 9 divide by 3. If you divide 9 by 3, you'll get the answer 3. 15 minus 3, the answer is 12. Okay, let's go for the B part. Let's read the question. Jacinta says, when we simplify 91 minus 35 divided by 7, we get 8 as the answer. Explain why Jacinta's answer is incorrect. Okay, so Jacinta, what he is telling is 91 minus 35 divided by 7 is equal to 8, it seems. But we have to prove that this is not equal to 8. So how are we gonna do this? Now concentrate, students. I told you we have a priority order. First you divide 35 by 7. If you divide 35 by 7, the answer is 7. From 91, if you subtract 7, you'll get the answer 84. 84. Okay, so Jacinta's answer is incorrect, right? So the correct answer is 84. So you have proved that Jacinta is incorrect. Therefore, this is the notation of therefore. Okay, therefore Jacinta is incorrect. Jacinta is incorrect. Okay. Question number 2, students, we are gonna talk about symmetry. It's the first lesson of our syllabus, symmetry. What is a bilateral symmetric plane figure? Write the number of axes of in each of the symmetric figures given below. Okay, now here they have given A, B, C, D. There are 4 figures, students. Okay. So they are asking in the first. One, what is a bilateral symmetric plane figure? They are asking what is bilateral symmetric plane figure. They are asking the definition. What is definition? What is the definition of a bilateral symmetric plane figure? So when we fold a figure or shape, figure or shape, figure or shape, figure or shape, if it folds along the axis of symmetry, what? Axis of symmetry. Okay, coinciding, what? Coinciding two parts of the figure or else shape. Coinciding, make sure to write the coincide. It is called bilateral symmetric. Bilaterally symmetric. So for an example, students, think of a rectangle. You draw the axis of symmetry like this. If you fold it, then when you're folding a rectangle, it coincides, right? So this is a bilateral symmetric plane figure. As well as in this rectangle, students, there is another axis of symmetry. Okay, or else the line of symmetry. If you bend it this way also, it will be coinciding. So they are asking some questions in the Roman number 2. Write the number of axes of symmetry in each of the plane figures. Okay, so since you have the textbook, students, I'll just tell you the answer. The figure is there in the textbook itself, so when you are concentrating on that, you can check the answers with your answers that you have done. So in the first figure, students, there are two axes of symmetry, because it is also a rectangle, but inside there are some different figures. We don't think about that because the rectangle obviously has axis of symmetry. When you bend it, the remaining figures inside the rectangle is also coinciding. So this is the answer, two axes of symmetry. So next one, question number B. It's a triangle. In a triangle, but they have given small part here. This one and this one is equal. It means this is an isosceles triangle. In an isosceles triangle, students, what happens is there is only one axis of symmetry. One axis of symmetry. Okay. Question number C. C also, it's a rectangle. It's a rectangle. It also has two axes of symmetry. Question number D. In the question number D also, you have two axes of symmetry. Two axes of symmetry. Okay. Roman number 3, they are telling draw the following symmetric figures in your square root exercise book. Draw the axis of symmetry and name them. So, students, this is a very easy question. So, you can try them. It's a matter of drawing the axis of symmetry like I have done in this part. So, yeah, let's move on to the question number 4. Question number 4. um, if the plane figure is cut along the dotted line, then it will be divided into two parts which coincide with each other. Is the figure bilaterally symmetric about this line? Explain your answer giving reasons. Now students, in the Roman number 4, they have given a figure like this. Roman number 4. We are doing the Roman number 4. I skip the Roman number 3 because it consumes time and it's a very easy question. You can just draw the axis of symmetry which I taught you in this theory. Okay. So in the Roman number 4, this is the figure they have given, and this is 5 centimeters students, and this is 3 centimeters, and a line is drawn from here to here down, and this is 3 centimeter and this is 5 centimeter. Now obviously students, now you can see this is some shape of a rectangle, right? This is a shape of a rectangle because these two side lengths, they have not given a respective length. But have we learned in a rectangle students we can draw a axis of symmetry like this? Obviously it's not, because when you are coinciding, now for an example, if you fold this from here to here, 5 does not coincide with 3 and this 5 will not coincide with 3. So what you are gonna tell, because the folded figure does not coincide. That's all. Let's go to the fifth question. For the fifth question, copy each of the following figures onto a square ruled paper and complete each figure such that the two dotted lines become axis of symmetry of the completed figure. Okay. So students, what you are gonna do? They have given in the question number A, B, question number 5, simple A. They have given you a dotted line like this, and they have given a line like this also. Okay, they are giving you a line like this. So what you're supposed to do? They are telling you to draw a figure such that this axis of symmetry and this axis of symmetry are the lines of symmetry of the figure that you are going to draw. Now make sure when you are drawing a line like this, they have given the line like this, no? So what you're supposed to do? What you're supposed to do is take the measurement of this length and draw a length like this here. Okay, and what you're going to do, connect these two lines, this one and this one. Okay, then you will get the figure. Okay, so this is the answer. So let's go to the next question also. Roman number 2. Okay, so this is a figure that they have given, and these are the two axes of symmetries of the figure. Same way, like you drew, like they have given in this figure, you make sure you draw the same pattern to this side also. Okay students, same way you should draw the same pattern to this way also, and again same way to this side you draw the same way. Can you see? You will get a perfectly bilateral symmetric figure. Here, from here to here also it bends, from here to here also it bends and coincides with each other. Okay, let's go to the next question. Question number 3. A set A is given below by listing its elements: A, 2, 3, 5, 6. Write A using a common property of its elements. So third question, Roman number A, they have given A equal 2, 3, 5, 7. So by looking at these students, these are odd numbers. These are odd numbers. Are these odd numbers? I was checking whether you are in the lesson. What is this 2? 2 is even number, and only these are odd numbers. Can we tell these as odd numbers? No. So we call these as prime numbers. Why? prime numbers are the numbers which is divided by its own number as well as what? As well as 1 only. So these are called as prime numbers. Prime numbers between 1 to 8, because 7 is included. So the prime numbers between 1 to 8. Okay. So Roman number 2, rewrite P equal factors of 12 by listing its elements. Okay. Roman number 2, they're asking you to find the factors of 12. Factors of 12. So how to find factors of 12, students? We have learned this. To find the factors, we find the LCM of 12. Divide by 2, 6. Divide by 2, 3. Divide by 3, 1. So the LCM is 2 times 2 times 3. So to find the factor, students, I taught you a method. First you round everything. When you are rounding everything, 2 times 2, 4, 4 times 3, 12. So 12 times 1. Again 2 times 3. Now since you are rounding off all the 3 numbers, now we are going to round off 2 numbers, which is 2 times 6. And again 2 times 3. Now we are going to round 1 number. So 2 times 2 is 4 times 3. So the factors are, students, 1 comma 2 comma 3 comma 4 comma 6 comma 12. You take everything which you got here, 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 here. Altogether there are 6 factors of 12. Okay, let's go to the next question also. Question number 3. Let A equal multiples of 3 that lie between 8 and 20. Write A by listing its elements. Okay, so let's list the elements. They are asking the multiples of 3 between 8 and 20. Okay, first of all, let's write the multiples of 3. So we know multiples of 3 are 3, 6, 9, 12, 15, 18, 21. But they have given us a condition. What is the condition? They are asking the multiples of 3 that lie between 8 and 20. Lie between 8 and 20. 8 and 20. So what we are supposed to do now is, we are not going to use 3 or else 6. We are going to use 9, 12, 15 and 18. Not 21. Why? It has exceeded 20. So we are going to write the set A equal 9, 12, 15, 18. This is the answer. Let's go to the next question. Represent A in a Venn diagram. So this one, when you are representing it in a Venn diagram, it's 9, 12, 15, 18, and make sure draw a line and mark it as A, because the set A is representing 9, 12, 15, 18. Okay, let's go to the next one. Question number 4. Write the set represented by the Venn diagrams using a common property of its elements. Roman number 4, they have already given us a Venn diagram. So it's 9, 18, 27, 36, 45. So this Venn diagram is represented by the letter A. Okay, they are asking us the common property. What is the common property, students? By looking at this, you can tell multiples of 9, right? Multiples of 9 from 1 to 50, right? Like that, 1 to 50, because they have not used the numbers which exceeds 45, right? So can the next multiple of 9 can be represented here? No. Now normally after 45 the next multiple of 9 is 54, so we can't use it. Why? It exceeds 50. Clear? Okay, so let's go to the next one. Roman number 4 is done. Let's go for the fourth question. Write the factors of 44. Okay, we are gonna find the factors of 44. So question number 4, Roman number 1, factors of 4. 44. Okay, so first what we are going to do, find the LCM. Divide by 2, 22, again divide by 2, 11, again you divide by 11, because 11 is a prime number. There is no any other number which is divisible by 11. So let's find the factors now. First we are going to find the LCM 2 times 2 times 11. So you can see you round everything. 2 times 2 4, 4 times 11 44. 2 times 2 times 11 it's, now what you're going to do, you rounded all the three numbers, now you're going to round two numbers. 2 times 22. Again 2 times 2 times 11, you just round one number. 2 times 2 4, 4 times 11. So the factors are, students, here another thing, 44 comes by what? 44 times 1. So the factors are 1 2 11 22 44. Question number 3. Question number 4, Roman number 2. Write the prime factors of 44. Out of these numbers, students, what are the prime factors? Prime factors are this 2, this 11, and that's all. All the other numbers are not prime numbers. So the prime numbers are 2 and 11, 2, 11. Okay. Let's go to the next question. Write 56 as a product of its prime factors. So they're asking you to write 56 as a product of prime factors. So what you are going to do, first you are going to find the LCM, divide by 2. 56 divided by 2, you'll get the answer 28. Again you divide by 2, you'll get the answer 14. Again you divide by 2, 7. And again 7, get 1. So as a product of prime factors they are asking, so what you are going to do, multiply all these numbers. 2 times 2 times 2 times 7. So 2 times 2 times 2 is what? 2 to the power 3 multiplied by 7. This is the answer. Question number 4. They are asking you to find the highest common factor of 18, 30, 42. 18, 30, 42. Okay. 18, 30, 42. How to do this? First, what you are going to do, you are checking. Now here we are going to do the highest common factor. Make sure we are finding HCF. When finding HCF, students, all the numbers should be divisible by the number that you are going to choose. If one number is not divisible by that number, you are going to stop HCF. Okay, you are not going to do completely until one comes. That is in the LCM part. Now let's first, now you can see 18, 30, 42. All the three numbers are divisible by 2. So divide 18 by 2, you get 9. 30 divided by 2, you get 15. 42 divided by 2, you get 21. Now next number you can see 9, 15, 21. Now you can't divide it by 2, but you can divide by another, which is 3. Because 9, 15, 21 are multiples of 3. So 9 divided by 3 it's 3, 15 divided by 3 it's 5, and then 21 divided by 3 it's 7. Now in the next part, students, we can't multiply a number which is divisible by all the three numbers. Okay, we can't divide these three numbers by one number, but we can divide 3 by 3, 5 by 5, 7 by 7. But in HCF they are not telling us to divide every number one by one by one. If all three numbers are dividing at once only, you are using. So the HCF is 2 times 3, which is 6. 2 times 3, which is 6. Let's go to the next question. Question number 5. Find the least common multiple of 18, 30, 42. 18, 30, 42. First, what you are going to do? Find the LCM. So 18 divided by 2, 9. 30 divided by 2, 15. 42 divided by 2, it's 21. Again, you are going to divide by what? What number you are going to use? 9, 15, 21. 9, 15, 21. Now, this you can use 3. 3, 5, 7. But we are not going to stop here because this is the LCM now. So again you are going to divide by 3 because 3 is already there. 1, 5, 7. Now again you are going to divide by 5 now. 1, 1, 7. Again you are going to divide by 7. 1, 1, 1. So the answer here is LCM equal 2 times, 3 times, 3 times, 5 times, 7. Okay. So 2 times 3 is 6. 6 times 3 times 5 times 7 is there. 6 times 3 is 18. 18 times 35. We should multiply. Let's multiply and see, students. 18 multiplied by 35. 8 times 5, 40. 5 times 1, 5. 5 plus 4, 9. 8 times 3 is 24. 3 times 1, 3. 3 plus 2, 5. So 0. 9 plus 4, the answer is 13. 5 plus 1, 6. So the final answer is 630. Okay. Question number 5. What is the digital root of 522? They are asking what is the digital root of 522. So 522 is there. What you are going to do? Add each and every individual number. 5 plus 2, 7. 7 plus 2, 9. That is the answer. You should divide. You should add until you get a simple one-digit number. If you get that simple one-digit number only, you are gonna use the digital root. This is the digital root. For an example, if you add everything comes as 19 for an example, then what you are gonna do? Add 1 plus 9. What is the answer? 10. But this is also not the answer. 1 plus 0 you add, then only you'll get 1. This is the digital root. Okay. But in this question, they are just asking a simple one. But in the exam, they might ask something like this. So make sure you study this and go to the exam. Next one, using the digital root, explain why 522 is divisible by 3. They're asking, using the digital root, explain why 522 is divisible by 3. So students, you can see the digital root is 9, right? We learned in the theory class, if the digital root is divisible by 3, then this number is divisible by 3. So what you're gonna write? Since. Roman number 2, since the digital root 9 is divisible by 3, the number 522 is divisible by 3. Simple. Roman number 3, using the digital root, explain why 522 is divisible by 9. Okay, so students, in this also it's the same logic. Since the digital root 9 is divisible by 9, it's not 3 now, it's 9. The number 522 is divisible by 9. Okay, this is the answer. Okay, let's go to the next question. How do we find out whether, without dividing a number, whether it is divisible by 4 or not? How do we find out without dividing a number whether it is divisible by 4 or not? Now students, in the textbook there is a theory part. Without dividing a number, how to find whether a number is divisible by 4 or not. Okay, normally I'll tell you what is happening here. Now normally, for an example, think about the number 16, the number 16. Okay, this number 16 is there. But is 16 divisible by 4, students? Obviously it's divisible by 4, because 4 times 4 is 16. Now think of another number which is 20. 20 is also divisible by 4. And next one, think 24. This is also divisible by 4. Now what is the relationship which is common for all these three numbers? It is an even number. That is an even number. It should be an even number. If it's an even number, students, it's definitely divided by 2, no? If this case is satisfied, you can tell that it should be even number and it should be divided by 2. Then only what happens, you can tell that the number is divisible by 4. Clear? Okay. Refer the note. You'll have the theory in this related to this question. Okay, let's go to the question number 5. 4, 3, 2, 1 are 4 numbers written on 4 cards. How many numbers which are divisible by 4 can be made using all these cards? Okay, how to do this? Okay, now in question number 5, 4, 3, 2, 1, there are 3 cards, it seems. Marked by numbers 4, 3, 2, 1. Now the theory related to 4. Now if it's a big number, 1, 2, 3, 4, there are 4 numbers. For that, what is the theory that we have learned in the book is, if the last 2 digits of the number is divisible by 4, then definitely the whole number is divisible by 4. So look students, I'm going to make some numbers here. 4, 1, 3, 2. 32 is divisible by 4, which is 4 times 8. Okay, and again I'm going to make another pattern as 1 3 2 4. 1 3 2 4. What I'm going to do, what I did it, I brought this 13 here and put this 4 to the end of the number. So 24, this is also divisible by 4. So what I'm going to do, I can interchange another number here. 3 and 1 I can interchange. If I interchange this here, see, I'm going to interchange 3 1 2 4. This is also another number, and again I can interchange 4 and 1 1 4 3 2. This is also a number. So how many numbers you can form? 1 2 3 4. There are 4 numbers which is divisible by 4. Okay, question number 6. Question number 6. Question number 6. If the number 5 3 blank, if the number 5 3 blank, if the number 5 3 blank, which has 3 digits is divisible by 9, which has 3 digits is divisible by 9, what is the digit in the units place? Okay, now they are telling this number is divisible by 9, then obviously the digital root should be how much? 9, because we have discussed here as well as in the theory class. So 5 plus 3, you don't know this. If you don't know something, I told you to put x, and you know the digital root, which is 9, because it's divisible by 9. So 5 plus 3 is how much, students? 8. 8 plus x is equal to 9. So x is equal to what? 9 minus 8, which is 1. You can logically get the answer also without doing the calculation. I told you the digital root is 9. So 5 plus 3 is what? 8. So you need how much to get 9? 1. So you can logically get the answer. So that is the way. So let's go to the next question also. Question number 7. Question number 7. If the number 5 3 question mark, which has 3 digits, is divisible by 6, then what is the digit in the unit place? Okay, how to do this? How to do this? Okay, now students, there is a theory part in the digital root lesson to make sure whether the number is divisible by 6. To make sure whether the number is divisible by 6, the number that you are getting here should be divisible by 4, as well as it should be divisible by 3. Okay, it should be divisible by 4, divisible by 4 and 3. Then you can tell that it's divisible by 6. So what is the number that you're going to put here? Should think properly. Okay, now see what, now I have taught you the theory of how to find the number which is divisible by 4. If the last 2 terms of the number is divisible by 4, you can tell that this whole number is divisible by 4. Now here's 3 now students. Now multiples of 4 is, you can tell 4 times 8 is 32. 4 times 8 is 32. Now I can put 2 here, but is it divisible by 3? No. So you should find a common term, common number which is divisible by 4 as well as 3. The best, the most appropriate number that you are going to put is 36, because 6 is divisible by 3 as well as this 36 number, the number 36 is also divisible by 4. So obviously you can tell that it's divisible by 6. So the most appropriate number is 6. Okay, let's go to the 6th question. 6th question. 6th question. 6th question. Find the value of 6 square. Find the value of 6 square. Find the value of 6 square. Question number 6. A, Roman number 1. Find the value of 6 square. So 6 square is 6 times 6, no? It's 36. Roman number 2. Write all the factors of the number corresponding to the value found in 1. So they are asking the factors. So what you're going to do, divide 36 by 2, which is finding the LCM. 36 divided by 2, you'll get the answer 18. Again you divide by 2, you get the answer 9. Again divide by 3, the answer 3. Again divide by 3, the answer 1. So the factors are, you are writing 2 times 2 times 3 times 3. So 2 times 2 times 3 times 3, the answer is 1 times 36. Okay. 2 times 2 times 3 times 3. How did I get this? Because I circled everything. I multiplied every number, and then you are gonna remove one number. So it's 2 times 3 is 6, 6 times 3 is 18. And again 2 times 3 times 3. Now you are gonna skip one number and multiply by the remaining two numbers. 2 times 2 4, 3 times 3 9. Again there are 2 times 2 times 3 times 3. There's another one number here. 2 times 2 is 4, 4 times 3 is 12. So it's 12 times 3. So the factors are 1 2 3 4 9 12 18 36. All these numbers are factors. Okay. Roman number 3, there are only two prime factors among the factors written in 2. Write down 3 more numbers where each of them has only 2 prime factors. Okay, now see, out of these numbers, what are the prime numbers, students? Here 2 and 3 are prime numbers. So the prime numbers are 2 comma 3. That's all. Question number B, Roman number 1. Question number B, Roman number 1. Expand a squared b to the power 3. So when they're asking us to expand, what is a squared, students? A times a. And b to the power 3 means what? B times b. This is the expansion. You expand it and you are writing. Roman number 2, evaluate x to the power 3 y to the power 2. Now how are you going to do this? First, what you are going to do? Expand this. How many x's are there? 3. X times x. How many y's are there? Y times y. And next they are telling us to evaluate when x equal 5. When x equal 5 and y equal what? Y equal 4. So instead of x you are going to put 5 times 5. Instead of y you are going to put 4 times 4. Now students, see, 5 times 5 is how much? 25. What is 5 times 4? It's 20. And what is there's balance 4 here. Write it down. Now here see, 25 times 2 is how much, students? 50, right? 25 times 2, 25 times 2 is 50. And there's a balance 0 remaining here. Now you put it here, multiplied by 4. You know 5 times 4. What is 5 times 4? It's 20. And there are 2 zeros remaining, so 0 0. The answer is 2000. Okay, question number 7. We have to just put right or wrong. Any multiple of 2 has only one prime factor. Okay, think for an example, question number 50. Think of a number which is 50. Okay, sorry. Think of a number which is 50. 50 is divisible by 2, right? It's 25. So 2 is a prime number. 50 is divisible by 5. 5 is also a prime number. So the statement that they are telling is totally incorrect. So for the first question, for the 7th one, Roman number 1, it's incorrect. It's incorrect. 5th one, Roman number 1, it's incorrect. Let's go to the Roman number 2. Any number which can be written as power 2 has 2 as its only prime factor. Any number which can be written as a power of 2 has 2 as its only prime. That is correct. Okay, because it's a power of 2, no, students. If it's a power of 2, it will never be divided by any other prime number. Roman number 3, any multiple of 3 has only one prime factor. Any multiple of 3 has only one prime factor. It's totally incorrect. Now for an example, think the number 30. 30 is divisible by 2. It's divisible by 3 as well as it's divisible by 5. So it's not only one prime factor. It has a lot of prime factors. Roman number 4, any number which can be written as power of 3 has only one prime factor. That is correct. Because it's a power of 3, now students. It increases by the power of 3. So what has happened? It will not get connected with any other prime number. Okay. Next one, Roman number 5. Any number which can be written as power of 5 has 5 as its only prime factor. That is also the same case, which is incorrect. Question number 6. The highest common factor of any two positive integers is less than or equal to their least common multiple. The highest common factor of any two possible integers is less than or equal to their least common multiple. Okay. Now for an example, students, think of the number 4 comma 6. Let's find the LCM of this first. 2 comma 3, again 2, 1 comma 3, again divide by 3, 1 comma 1. So the LCM is 2 times 2 4, 4 times 3 it's 12. Now let's find the HCF of this 4 comma 6. You divide by 2, 2 comma 3. So this is 2. Now this is the HCF. Now let's go for the question. They are telling you the number, the highest common factor of any two possible integer is less than or equal to their least common multiple. It's correct, no? Less than or equal, right? The HCF is less. So the question number 6 is correct. You tick it. Okay. Now let's go to the next one. Question number 7. The highest common factor of any two distinct prime numbers is 1. Yeah, it's correct, because a prime number is only divisible by its own number and 1. So all the numbers are divisible by 1. Therefore, the question number 7, the answer is correct, because any number is divisible by 1 itself. The highest common factor of 12 and 13 is 1. The highest common factor of 12 and 13 is 1. Correct, because 13 is a prime number and 12 is a even number. Now a prime number and even number is there. Definitely the highest common factor is 1. That is also correct. Question number 9. Simply they are asking us to add the following. So they have given years, months, days. 3 2 6 8 19 20. You add. When you adding, students, 9 plus 0 it's 9, 2 plus 1 it's 3. But you can't keep 39 here, because 30 days is equal to 1 month. So you remove 3 and put here 1. So 6 plus 1 is 7. 7 plus 8, you'll get the answer 15. Are you keeping 15 here? No, because you have to send 12 months to here, so that it will become 1 year. So from 15, if you subtract 12, you get the answer here 3. And 12 goes up, which is 1. 3 plus 1, 4. 4 plus 2, 6. The answer is 6 years, 3 months and 9 days. Next question, number 2. Years, months, days. Years, months, days. So here 16 is there, 7 is there, 9 is there, 3 is there, and then 21 is there, 9 is there. Okay. Now what you're gonna do? Add. 21 plus 9 is 30. You're not gonna keep this. You're gonna put 0. You bring this 1 here. 9 plus 1, 10. 10 plus 3, 13. Are you keeping 13? No. You keep one month here and bring the below remaining 12 months, which is equal to 1 year. 6 plus 1, 7. 7 plus 7, 14. 1 plus 1, 2. So 24 years, 1 month, 0 days is the answer. Question number B, Roman number 1, is a subtraction. Years, months, days. 6 8 12. 6 8 12. 6 8 12. 4 5 20. 4 5 20. You subtract. When you are subtracting, students, now see, you can see clearly you can't subtract, right? So you are going to borrow from months the days. So 1 month has 30 days. So altogether this becomes how much? This becomes 42, because 30 is added. So 2 minus 0 it's 2, 4 minus 2 it's 2. So you gave 1 for the days, so it's 7. 7 minus 5 2, 6 minus 4 it's 2. This is the answer. Next question, YMD 5 7 19, and then 2 9 25. So this is a subtraction. What you are gonna do? You can't subtract 19 by 25, so borrow 1, which is 30. If you add 30 plus 19, this becomes how much? This becomes 49. This becomes 49. From 9 you subtract 5, it's 4. From 4 you subtract 2, it's 2. So now you gave 1, no? What is the balance here? 6. 6 minus 9, you can't subtract. So you ask 1 from him. After asking 1 students, 1 year is equal to 12 months. 12 plus 6 is 18. Okay, this becomes 18 altogether. 18 minus 9, it's 9. So you gave 1 year for him. So you are remaining with 4 years. 4 minus 2, the answer is 2. So this is the answer of the ninth question. Okay.